Let's see how to make PMOS diode connected NMOS common source amplifier. So here instead of resistor we are using the PMOS transistor. So for that I'm just going to create a new project and go to the new component, and initially I need to build the NMOS common source amplifier. So we are searching for this NMOS monolithic transistor. Okay, let's place this transistor. And in the NMOS always it follows drain, gate and the source. So now okay, we need the two voltage sources. So this is for the input, and here we want VDS and this is a VGS. Okay, then we need one resistor. Let's place this resistor here. So actually this resistor we are now going to replace with the PMOS transistor. That's why it is called as PMOS diode connected common source NMOS amplifier. Okay, instead of this we need a PMOS transistor. So I'm just cutting this and I'm inserting another PMOS transistor. Okay, for the time being let it be the resistor. After the completion of this circuit we are going to replace this resistor by the PMOS common source. No, that's the PMOS transistor, that is the diode connected PMOS transistor. This is the input and we need ground for these things. Okay, now we will join the wire for our circuit. So from here to here and from here to from here to here and from here to I need a wire, and from here to here, and this one we need to connect to the input of our NMOS transistor, and from here to here, and this will be from here to here. And always remember the base is connected to the source, that's why we need to connect it here. So this is our simple NMOS common source amplifier. So now we need to replace this resistor by the diode connected PMOS. That's why we are removing this resistor, and in place of resistor we need to insert the transistor now. So we need to search for the PMOS, that's also the monolithic. Okay, let's connect this PMOS, and here we need to connect from here to here, and this PMOS always remember this is basis has to be connected to the source. The source is the above one. This is exactly opposite of this NMOS. Here it is connected to the downside, that's drain, gate and the source, and here the drain, gate and the source. That's why it is connected here. And from this gate and the drain has to be shorted. So from this one we need to connect here. So okay, so this is the gate and this is the drain. These two gets shorted, so it becomes the diode connected PMOS. Now we need to set the values for this circuit. So this is our input, that we can give this as a sine wave. So I'm just going to the sine wave and the DC offset. Okay, let's see 0.68 or anything 0.7. We need to maintain that NMOS in the saturation region. And let's say this is a 1 millivolt, and let it be the 2K frequency, and this one be 1.8 volt. Now we need to set this length and the width 1 micro, and let this be 100 micro, and here too we need to set, so let it be 1 micro and 100 micro. Now this is okay, and this is, and this one and this one. Okay, now let's run the circuit. We will do the transient analysis first. So stop time will be 1 milli and the start is 0 and 10 in the increment of 10. Now if you want to see the output, we need to see here. Okay, this is from 1.2 to 1.1 to 1, so this is too less. So okay, let's change these values from 0.682, we will just make it to 0.6. Okay, now we will run this, and we even need to change this to 10 micro, and we will see. So now this is from 252.7 to 253.2. It's too less. It's not even a gain of 1. Let's make it as 0.72, and we'll just check it out. Now this is just a zero point 0.8, the gain of just a 0.8. So we'll just change these parameters. I think changing these parameters won't affect our circuit if we minute changes. So 161 to 162, 162.05. So we will change this to 40. Okay, I'll just make it as 410. We'll change this to 40, and we'll just look at the circuit now. So this is will be from 510.7 to 511.6 millivolt. That means just a 1. Okay, so this is just a almost we are getting the gain of 1, but that's too less. So we need to build something extra, that means some advanced version of these kinds of circuits, because we are getting the gain is very less. If we interconnected these NMOS with the diode connected PMOS, we can change these values and we can see the gain will not seems to increase very much. So the gain is less in these kinds of circuits. So if you want to do the DC analysis, then okay, we will just try to make the DC analysis of the circuit. So I just, okay, not this one, I need to go to simulation, has to be in the circuit, and go to simulate and control panel. No, I need to go to the edit simulate. Okay, so this one, edit simulation command, and okay, DC sweep, and here this is the V1, and V1 we need to sweep from 0 to 2 volt and the increment of 0.1. Okay, let's check it now. So here already one transient is there. So okay, we just check the circuit now, how this will going to provide the, yeah, it's almost like this. Okay, so for the, when we click here, we can get the for the different values. So here we can see for 100 milli, 200 milli, until it reaches the, oh, I think we forgot to add the dot model properties. That's why it is something the gain and all it is taking from the default one. Okay, let's write those two things and let's check it out. So dot model, because we not specified what is the cutoff and what is the KP value. So dot model PMOS. Here we have the both PMOS and the NMOS. So KP equals to 200 U. Okay, then VTO equals to minus 0.6. So okay, so this is for the PMOS, and similarly we need to have for the NMOS. We need to have this VTO as 0.4, and I need to change this to, instead of PMOS, I need to have this as a NMOS. Okay, now let's run the circuit. Yeah, now it is taking, that means it is considering these cutoffs as a 0.4 and it's giving the proper output. Now if you want to see this transient analysis again, okay, let's make it as a dot tran, and here we just make this to the comment, or we can just add the comma at the beginning. And if we run and if we want to see the output, okay, it is somewhat 494.1 to 495.6. So it is around 1.4 or something. The gain is too less. Yeah, I think you understood this circuit, how this will going to work. Make sure you added these two properties, Kp and the VTO, and this is the what the PMOS diode connected common source NMOS amplifier. That's it. Thank you.